So my name is Zaki Patel. Unfortunately, my other team members aren't here with me today. There were two other people working with me in Toronto, and there were two other people globally, one in Indonesia and the other in India. So the challenge that worked on was the tour of the moon, and we were asked to create a web application that enabled humans to interact with a 3D image of the moon, which had images overlaid from a GRAIL mission, which is basically they had these two spaceships that were orbiting the moon, and at different points in time, there were high-resolution images that were taken, and there were about close to, I think, 300, 400,000 images of very high resolution. So that was our challenge, was to build a web app which leveraged this NASA data set and enabled people to sort of, for an educational perspective as well as for awareness and just generally for the public to be able to access what the moon looks like, where some of the important landmarks are, like the big craters, where the landing sites were, as well as other data sets like what the terrain elevation is like in different areas. I have a video. I'm not going to be able to demo the application, but it works. It's just a performance challenge, which I don't want to take a risk on. So some of the features that we have implemented was we have a 3D model of the moon. We've been able to overlay mooncam images from the GRAIL mission on top of this 3D model based on the location. We have the ability to do a search based on the latitude and longitude, as well as based on a particular hour during this mission when photographs were taken. We have also overlaid terrain elevation data. So we have a heat map which shows sort of the different elevations of the craters on the moon's surface. And we have the ability to auto-identify all the craters using an existing data set. The technology that we use is essentially the Google Earth and Moon API, which we leveraged heavily as using JavaScript, and the application is built using Ruby on Rails, and predominantly trying to leverage existing data sets. So I'm going to try and speak fast so I can keep track with, align with the timing of the video. So what we have here is essentially a 3D model of the moon, which we use the Google API to implement. As you can see, as you zoom into it, there's not much detail to tell you about the texture. I mean, sure, you can see there's a crater over there, but you really can't tell anything about the crater other than that. The first task was to do a basic overlay, which is basically taking images from the mooncam, which is online, and overlaying them onto the 3D model of the moon. So as you can see, that was just two sets of files, and there's a whole bunch of other files which you've been able to kind of import and overlay onto this. And these are basically high-resolution files, so you can see the detail. Another feature we have is the ability to kind of auto-identify the crater. So you press a button, and it kind of tells you what the crater is and what the data points associated with that crater are, like the latitude, longitude, and the diameter of the crater and when it was identified. We also overlaid terrain elevation data from the Apollo metric camera, which gives us a heat map of basically the moon. And this is the Apollo zone where most of the landings were. And we're able to kind of drill down and see a particular point in time. So here what we're doing is we're flying to the Lambert lunar crater, and we're able to see the different in elevation, which is reflected by the heat map. The next feature is basically we picked a latitude and longitude, and it's sort of overlaying all the images based on the selected latitude and longitude. So as you can see, for a particular point, images are taken at different times of the day, and different times are obviously reflected with a different shadow and a different texture. So part of the features that we want to build is for people to basically rate these pictures so that we can eventually get a set of good quality pictures, as well as to be able to correct some of the data points in here so that people who want to reuse this data set can then get a improved version of some of the sort of images so that the craters are in the right location. And the best part of the demo is coming up next.
Can't do it.